myself. My name is Stefania Truffa. I'm the co-owner of Project Up 360. And within the EcoeFISHent project, I'm the project manager, and we are the organization that supported the development of the project from the very beginning, of course, together with other partners, which were the scientific partners. First, among the others, the major one was the University of Genoa, of course, and the Professor Elena Gasselli, which is the director of this course. And I'm here today to explain how this project has been developed and also how it's structured. I believe it can also be interesting for learning how European project or research and development project is structured, developed, and managed. I also want to say that we are talking about let's say, a special project. EcoeFISHent is one of the last projects that has been funded by the European program called Horizon 2020. We are now actually in the other European framework program, which is Horizon Europe. But EcoeFISHent has been funded in the framework of the Green Deal project, the Green Deal cause. They really wanted to finance, to fund the new opportunities related to the Green Deal policies that the European Commission set in 2020. And so this is one of these challenging projects. Another particular characteristic of the project is that this is a big one. Let's say we have, as you already seen in the previous presentation, we have 34 partners, which is quite huge consortium, which is really above the average for research and development project, or in case for an implementation project as our is. And this is the third particularity. So we are talking about research and development project, but with the aim of really build something concrete and real that will be present in the territory after the end of the project. So we're not just thinking about developing new technology, but implementing a new system in a specific area, geographic area, that will be something that will really change the economic sector or some of the economic sector which are crucial for the territory. So we are talking about Liguria, so fishing is one of the main economic sector for the region. So that's why the project is really, let's say, a game changer for the territory. Okay. So I'll put in presentation mode. I'm sorry for that. Okay. So why EcoeFISHent? Okay, from what we started at the very beginning. We wanted to go back to the future of circular economy. What do you mean with this? We mean that, humanity, people in the past year, in the past centuries, and also very early in our history, had the habit not to waste anything. So anything was, every resource was kind of reused, or not say recycled, but revalorized, or put in another chain of consumption and utilization. So what we can say is that in the past, economies, society were much more careful not to waste the few resources that were available, and also to valorize all the important resources that the ecosystems were giving to humans, and also that were also the results, of course, of the work of the people. So EcoeFISHent aims to go back to these models, which are new now because we are used to talk and to live in a linear economy model, but really it's something that if we talk about few generations before us, the circular economy was something that was really in place every day in our sector. So our aim is really to valorize valuable resources that now are considered side stream or waste and are treated as waste with a burden which is both economic and environmental for society, for companies, and for the planet. So this is an example of how back in in the ancient time, the side stream coming from the fish industry, of the fishing, we cannot say industry, of course, in back at that time, but the fish activities already produced side stream, but nothing was wasted, but there was something that was used for human food. Okay, so this is not something that we are doing in the project, where we are not dealing with human food, but with the valorization of important part of the side stream that are now available in huge quantities in the fishing industry and for fishermen. So we starting from this awareness. The awareness was that in every fish, apart from what we eat, there were a lot of valuable molecules, valuable materials that can be reused for the human consumption, even if it's not food consumption. Okay, so this is our starting point, to valorize and not to dispose or incinerate something which is really valuable at the moment. So this was our idea, what to do with all these important molecules. So these are our first ideas. We saw that, we had DNA, we had lipids, calcium coming from different parts of the fish that with different processes could be dried, extracted, purified, and used in several industrial applications, which are added value application. We know that, something that is used in cosmetic, which can really be valorized both economically and as its use, its benefit for the human. Same is if we use something in the nutraceutical sector on the bioactive. So this is what we want to do from our awareness that from the fish biomass that at the moment are disposed, we can really obtain something of value. These are the main challenges we wanted to apply to. The first coming from the fish processing side stream, which at the moment are underexploited, because most of them are actually used in low-value products, such as fish oil, fish meal, so feed with low protein value used for the breeding of animals, which can be again for aquaculture, so kind of closing a loop, or in other kind of animal breeding. But we also know that this is a valuable content that should be used for something else. So let's say, let's think about, the impact that now we have in producing proteins for, human consumption. We know that, producing proteins from cattle, from, other kind of animals, as is one of the biggest industry that created the biggest impact on climate change. This is already assessed since many years. And if we think that we discard up to 70% of the fish biomass, which has a high content of protein. So if you think of this doesn't really make sense also in according to all the goals that we have for reducing our carbon footprint, reducing in general our environmental impact. So the need that we have answered is to have more circular, natural, and sustainable product in cosmetic, food, and also in feed for animals. But there are other challenges we are facing, which are not linked to the organic part of the fishing side stream, but are linked to the industry itself. And it regards the plastic part. We know that the plastic pollution, particularly in the oceans, is one of the main concerns together with the climate change. And we know that in the sea, 85% of the litter is from plastic, and from these, the 10% are coming from the ghost gears. Ghost gears are, the fishing nets, which are lost by fishermen, both professional but most of them are, for sport fishermen, and these are lost, and these can be found in the seabed, and represent 10% of all the plastic marine litter. So it's quite a big percentage. Another important challenge that we are facing is always relating to plastic, in this case for the packaging of the fish. So which, as many of you know, are sold in APS packaging, which is not recycled because it's contaminated with fish. Now there are in these years some technologies, some new technologies that can recycle the APS was developed, but most of them are not. And these are big numbers. So these are 350, 100,000 of tons per year, only in the countries of the European Union. So this is a huge quantity of not recycled plastic packaging at the moment. And so this is other needs. The needs are coming, both from, let's say, actual need coming from the environment. We know that we need to change our habits, but the needs are coming also from regulations, from new policies given by the European Commission, which sets that, some important goals for reduction of our carbon footprint, our impact, or changing materials for our packaging and for our daily consumption. So how to bridge this challenge, opportunity, and these needs? EcoeFISHent wants to be the bridge, wants to answer to these challenges, giving solution in the local territory, but that can be replicated in all Europe. So this is also one of our main goals. So instead, as a cluster which is locally defined, but a cluster that can be really an example and let's say a best practice for other similar territory all over Europe. Industrial symbiosis is the means through which we connect this challenge with the needs. So this means that we interconnect different industrial sectors in order that the byproduct, the side stream, or what is now a waste for an industrial sector can become a valuable raw material for another sector without further exploiting the natural resources of our planet and of our ecosystem. So this, as I mentioned before, the main challenge we started from because the current practice of fish processing is generating up to 70% of side stream. And of course, this depends by the species we are dealing with, but some actually are even more than 70%, but as you understand, it's a huge quantity that has been discarded dealing to big environmental problem, or as I mentioned before, ending in the production of low value products. So not giving to them the right valorization. But this is the fundamental of our project. So we know that in each of these, in all these biomass, there are valuable ingredients like oils, proteins, peptides, collagen, gelatin, enzymes that can be really valorized. But the question is, if we all know, all of us know that there are so many valuable content in this side stream, why it's not valorized? Why is it so difficult to transform this waste, this side stream in valuable products? Because this is not something new. This is something that scientists already know since many years. The point is the easy degradability of the fish side stream, as all us can imagine. You know, as fish becomes a waste, is strongly contaminated. Is with histamine, bacteria. So this is the main obstacle for its valorization, because also dealing with the conservation, collection, transportation of this side stream, it's not easy. It's a burden. So at the moment, with the current technologies, with the current system, it's easier just to give them to specific collectors that are authorized to collect animal byproducts, and then that can be incinerated or transformed depending by the kind of the value chain we are considering, depending by the industry we are considering. So the real enabling technology, the real enabling, let's say, part of our value chain that will allow us to really exploit the value of this important volume of size stream is the pretreatment process. So the pretreatment process that is being developed in EcoeFISHent and that will be set in different partner premises will enable to preserve this fraction, this bioactive, while valorizing them and drying them without losing their properties. So this is called the pretreatment process that I'll show you also to you later on. And this is the, let's say, our enabled technology for the valorization of the size. Other important data which give us the important role of EcoeFISHent in this sector of fish production is the numbers related to the sector, which we are talking about millions of tons, hundreds of millions of tons of global fish production. That if you compare to what we said before, the discard part up to 70% of the biomass, you can imagine how important it is to give a solution to this low valorization of this size stream. There's also a rapid growth in the fish processing, which generate important size stream because now also the consumer models have changed and people want also this ready meal, ready processed food, and this generates, of course, substantial size stream. But this is good for valorization because this means that most of the size stream are at the same premises and are not, let's say, dislocated, or they are not spread in homes or in places where it will be difficult to collect them and treat them and then valorize. Other important challenge, our important starting point is the necessity to use in an efficient way the biomass feedstock in order to contribute to European industrial and economic growth. You know that Europe, in many cases, the industry is not is transforming economy from a lot of fish also coming from other countries. So this means that if we can really valorize all the resources that we have, this can boost the economic growth of European Union, and also, of course, to reach the big challenges that Europe gave to all the member states to reduce the greenhouse gas emission. Europe is the first continent that has this ambition to become carbon neutral, or at least to reduce an important percentage its emission according to the last policies that are based on the Green Deal and also on the Fit for 55 policy. So using waste, using size stream as valuable material can reduce, of course, the environmental footprint and the carbon footprint of all the European economy. We have also a picture of the importance of Italy in this sector, because, as we mentioned, this project focuses to create cluster which is geographically located in Italy, in Liguria. So Italy's important role worldwide in this sector, being the second largest producer of Mediterranean fisheries. So this means that we should replicate this model also in other parts of the countries. I saw there's a question, or I go on? I continue. Okay.
I'm not seeing any questions.
No, I see someone raising hands, but
yes, maybe if you want to ask something to the professor, you can use the box for the questions.
This is something that we already seen before, you know, the huge amount of plastic marine litter and, you know, the most important amount deriving from the ocean, plastic litter from the ghost gears. Ghost gears are not impacting also for, you know, the bycatch challenge. This means that 5% of the total world fish consumption are ghost fish from the ghost gear. And bycatch is also an important issue that we are facing in EcoeFISHent, since bycatch are let's say fishes that are not caught on purpose. So while I want to maybe fish some species or some dimension of fish, some other smaller of other species are also caught at the same time. So the best percentage is very high because it's up to 40% represented by catch. So this is because there are not selective fishing practices, which is another challenge that our project wants to address. Another challenge in our project is the employment and the growth of the blue bioeconomy, which is an important segment of the economy and which can really help in performing novel, sustainable solutions. So if we can at the same time implement a new business model that can preserve resources and then can save emissions, at the same time creating new jobs, this means that we are really addressing two of the dimensions of sustainability, which are the environmental dimension and also the social dimension. So now we switch to the EcoeFISHent solution, which, as I mentioned before, are really including all the aspects of sustainability in its approach. Since we want to create positive impact in the economic dimension, in the environmental dimension, and also in the societal challenges. We also want to really make a difference at policy level, giving guidelines, giving suggestion, advice on how some of the regulation and some of the policies can be transformed, can be changed in Europe in order to really enable the circular economy, the industrial symbiosis in the fishing sector. EcoeFISHent has specific project objectives. So this is the first is to develop circular value chains, new circular value chains. This means with circular value chains, we mean value chains that really are fed through the side stream of another system, and it can be at the end again maybe the product be recycled or reused. So our aim is really to create 100% circularity, to preserve ecosystem, and to find sustainable territorial solutions in order that we give concrete demonstration of what can be done with this new business model, with these new technologies, and this can be really have an impact on people in the territory. The key objectives of the project are to, simplify the production and extraction of value-added products in order to really have the possibility and opportunity to use this value, and to reduce the logistic related to biomass degradation, as we already mentioned before. So this is also one of the reasons why all this system is locally based, because of course logistic time is important both to allow the valorization of the biomass and both to allow efficient use of the resources, both in terms of environment and in terms of economics, because moving mass from one place to the others means cost and means, of course, CO2 emission. So as much as these value chain are local, the best in terms of efficiency. So that's why our project is called EcoeFISHent, because we really want to have efficient solutions, and efficient solutions are the only way also in which industry really can adopt new models of creating values, new model of interaction with other sectors and with other industry. Because as you know, all the industry are very interested in new industrial sustainable business model, in new implementing sustainability in their processes, in having sustainable product. But of course, they should be sustainable also under economic point of view for the company. This is the only way in which we are sure that new technology, new solution can be a success at industrial level. This is what we do. EcoeFISHent does side stream cost, because now managing side stream is a cost. Especially considering the animal byproducts, which are collected with a specific collectors. This is not like the urban waste that is collected normally. So this means a burden, an economic burden for companies, them. So this means this again, we turn to the economic efficiency. So we can turn side stream cost into economic value. We can really generate something that can be implemented in different value chain. Another value chain that we are focusing in is the generated from the agri-science stream, which can be transformed in APLA, which is a bio-based polymer, and so the packaging for the fish can be converted by fossil-based packaging to bio-based packaging. In the packaging sector, we also want to generate a new product, which is coming from the fish biomass, producing a gas barrier packaging. So the aim is to create fish packaging from the fish itself. For completing the exploitation tool, another technology, a bioconversion technology, is also implemented in the project, which are the living black soldier flies lab to produce fertilizer, biodiesel, and chitin. So we see that from few side streams, we will have many different products involving important number of industrial sectors. In relation to the challenge for society that we are also addressing, one of these is linked to the collection of aquaculture and fishing nets to transform these in automotive components and cosmetic product packaging. This is really important issue since at the moment there isn't a system for collecting the nets. So this is the first step, not really the recycling, which of course is challenging technology, and we also need to develop it, but the most important part in the project is really to create a system for collecting the nets, because now fishing nets are just considered like urban waste. There is no way to separate them and to give to fishermen the opportunity to collect separately. Another important issue is linked to the selective fishing practices to reduce bycatch, and so this is something that is developed in the project by the development of a specific tool for selective fishing, which is going to be used in the Area Marina Protetta of Portofino by the fishermen of Santa Margherita di Bue, and which allows them not to exploit more than necessary the animal setting of the area. Another important challenge which are addressed is the stakeholder network involvement, in order that every actor which is called to give contribution to this cluster can really be informed, can be aware of the necessity of taking new action and of implementing new behavior for reaching the goals of circular economy. So the main objective of the project is to implement a demonstrable and replicable cluster for multi-level circular value chain. The multi-level means what we said before, that all these value chain are strictly interconnected, and that from the results of one value chain can really implement a new other value chain, And not only by considering, let's say, side stream, but also in a cascading approach, which means that from the same amount of the same biomass, we can feed different value chains, because the extraction, the valorization can give different bioactive, different valuable molecules. So the keywords which are recurrent in our project are mainly cluster, interconnection, and policy and regulatory framework, which is something that we mentioned before, because this really, we faced many obstacles to deal with the current policy and regulatory framework, because this is not set for this new thinking, for these new models. So it's something that during the year should be changed in order that the European Commission can meet the goals that it has given to all of us, and according also to the circular economy strategy, which has been already issued by the European Commission 5 years ago in 2018, and has been reviewed in 2020, but still we need for sure to improve this framework in order to be able to really implement a new business model. These are the consortium, the 34 international partners. Many of them are based in Italy, let's say in Liguria, in Pavia, Piemonte. This also is a special feature of this project, because we are talking about the construction of a specific territorial cluster. So this it's not, let's say, the standard for the European project, which in general involve more different countries in the project itself, in the consortium among the partners. And in fact, you can see that the geographical distribution is quite concentrated in Italy, which is quite strange for this kind of developing project. This is the project timeline. This is also another difference, another element which differentiates the project from the average project, because our project will last 16 months. Now we are currently past the first 2 years of the project, so this means that we still have 3 years to go. And our project is also divided in 3 main phases. The first phase, which just finished, is related to the optimization and integration. This means the optimization of the processes that will be implemented, and integration in order to integrate expertise, integrate different technology, which are the know-how of different partners in the consortium. Now, after the second year, at month 24 of the project, the scale-up and validation phase has just started. And this phase represents an important part, because this means the transfer of the technology from a lab or semi-pilot scale to a pilot scale, and also in the territory, so in the cluster territorial area, in order to really set the basis for the third phase of the project, which is the demonstration phase. In the demonstration phase, all the pilot of the project will be functioning. also the logistic that is going to be set, the framework and the application that support the logistic among the nodes of the cluster will be functioning. So this is the first part of the demonstration that will be at semi-industrial phase, allowing at the end of the project to really set a new industrial process for the valorization of the system. This is all our Gantt with the different tasks and work packages, but what I want to show you is that the project is divided in 8 work packages, which are very articulated because the project is very articulated and includes many technologies. So, but the first work package is dedicated to the management of the side stream, for all the side stream, and to define the logistic and the compliance. So, of course, we need to be compliant to regulation, even if we saw that there are some limits, and this is an important study of our work package 1. In the work package 2, there is all the part dedicated to the turning of side stream in added value resources for the cosmetic, nutraceutic, agriculture, energy, and packaging sector. So all the sectors that are involved in the transformation of side stream in valuable product. The third phase, the third work package, is for the bio-based product manufacturing and final product application. So from the extraction of bioactive gelatin, from the validation of the bioconversion pilot, we move to the production of the final products, which will be food supplement, which will be cosmetic products, which will be biodiesel, fertilizer, new packaging, and we counted, if I remember well, 17 final products that will be produced at the end of the project. In the WP4 is dedicated to all the technology and products which are related to plastic and bioplastics. So for the recycling of plastic and the production of new bioplastic products and materials. The work package 5 is dedicated to the cluster ecosystem economic, environmental, and social assessment. So this means that in this work package we will define which is the real environmental and economic impact of the products that we are going to produce and all the processes. And in this work package we will also develop the economy action plan for the territory. The 6th work package is dedicated to the ecosystem cluster modeling, including the replicability, because as I mentioned before, this cluster should be a best practice, an example for all other territories which have a similar situation, so big important fish industries, economy based on blue economy. But of course, not all the territory, not all the situation, not all the industry are the same. So to the development will be digital twin, we will be able to create models to understand which is the best solution for the specific territory. Finally, we have the work package dedicated to the communication of the project and the dissemination of the results, including the involvement of the communities. And this is also an important activity that is really not usual for European project, which is nudging activities. This means having the final objective to change the behavior of the community that should be involved in this new business model. And finally, we have the work package dedicated to management and coordination of the project. The project, you already have a picture, but the project is based on 4 interconnected pillars, which are the bioactives from the fish side stream, the ecosystem preservation, the part related to the digital support for the cluster and for the applicability, and the pillars linked to polymers and biopolymers development. Everything is, of course, interconnected, and in the middle of these pillars, what is very important is the communication, the training, and the stakeholder engagement to really implement all the actions. So for the biomass side stream for fish industry, as we mentioned before, this is, to turn the side stream into economic positive value, having efficient exploitation and developing innovative products. This is the representation of the pre-treatment pilot unit, which can really enable the first step before destruction in order not to degrade the biomass. In each step, you will see also the reference partner. So the second step is the extraction process, which are developed by important research centers and universities in Europe, which we have long experience in this area. And the result of this will be the development of a pilot unit for extraction that will be set at the University of Genoa by mostly at the end of the project. Another important activity technology of for the valorization of biomass side stream is the bioconversion to larva grading. In relation to the polymers and biopolymers, we will analyze 2 different types of nets, one dedicated to fishing nets, the other aquaculture, which are different materials. So from them, different products will be produced. And also to substitute the boxes with bio-based foam boxes. This is an example that you can see of bio-based boxes, which the design has also been developed according to a patent technology. And these are the involved partner also for the development of the new bio-based packaging. And you can see some of the pilot that will be used for these processes. All of them, again, are important research center, and while the partners that are in charge of the scale up of some technology are industry involved in the sector. Ecosystem preservation instead is related to the cleaning of the seabeds from the ghost gears to avoid further marine discard, and also to implement a new selective fishing tool. The last pillar is dedicated to the digital platform and support. So this will support the lowest environmental footprint, guarantee the efficiency, the cost effectiveness, to an app that will also indicate when the materials are ready, that will connect all the partners of the different value chain, and also the structure, the side stream provider. And for the scalability, the digital twin, which will be based on the same data that will be used for the logistic platform plus others, through real-world data capturing that we consider material flows, energy flows, value streams, and will define the right KPIs in order to provide optimization, simulation, and this will also be used not only for applicability, but for continuous optimization of the cluster itself. These are some definitions to remember. What we call co-products is something that is produced along a process with the final product. The side stream instead are not represented by product, but are not even intended for human consumption. So these are some of the definitions that are current in our project. So I will leave the floor to my colleague, which is also being involved in the development of the project, that will analyze and explain the cluster key objectives. Massimo Perucca.
Hello, Massimo is speaking here. So thank you for your patience and your attention up to now. I try to summarize and explain briefly the cluster key objectives. And let's start with the first objective. So we want to provide an innovative, demonstrable, and replicable territorial multi-level circular cluster to connect private and public stakeholders. What does it mean? Multi-circular level means that we have several circular value chains, and they are interconnected and are considered and developed at different levels. So interrelating and interconnecting several stakeholders. And all stakeholders are mainly involved in the coherent geographic area, so in the cluster itself, which is centered in the Liguria region, as it was previously specified. And we want to also have a systemic approach in order to involve industrial sectors which are not directly or not expected to be involved in the fish industry value chains as it is traditionally conceived. So what is a circular territorial cluster? There's a definition. There are many works developed in Europe and also many examples. This is a social, economic, and environmental system composed of all relevant actors and dimensions to implement, demonstrate, and facilitate the replication at least one circular systemic solution. So different stakeholders, different profiles, interconnection between these 8 stakeholders, and according to the systemic approach, providing a framework that could be also replicable in other contexts. So this is a really multi-level design, and we also have a meta design to this cluster. So a systemic solution is a cross-sectorial demonstration project for the territorial deployment of a circular and climate-neutral economy. So this cluster, this systemic solution, this implementation has a main objective of harmonizing the environments, so the environmental compartments involved, and the anthropic activities and the technosphere. So ecosphere and technosphere will interact in a very well harmonized and optimized level. To clarify a bit these concepts, we have here a chart that somehow is explaining, expliciting the profiles of the stakeholders involved in the cluster. And as we can see from the chart, there are some vertical and horizontal interconnections, and also institutional connections. So this is really multi-level and multi-profile cluster. Basically, we have from the top classification, logistic and transport, which is part of the cluster, which is in charge of displacing goods and to assure efficient material flows. We have testing laboratories that allow for compliance with law regulations at local level, at European level, for the management and transport of material flows, which, by the way, are considered side streams and not waste. So there is a well, not a trivial issue related to this classification of material flows and material themselves. Then we have local authorities and institutions and stakeholders, and there is also an IT platform management, which will somehow oversee and monitor the efficiency, the criticalities, the timing of the flows and of the values that is being transferred from cradle to grave or from cradle to cradle, because we are now indeed circular in this design. And then we have compliance experts that provide and design the right way to manage and to process the side streams according to good manufacturing practices, according to regulations and normatives that have the compliance with respect to the material flows and to the target exploitation objectives. So depending on what the side stream will be transformed to after extraction. We have here technology providers as a classification, marine ecosystem preserving and restoring reference experts, final products manufacturers, and side stream providers. So there is a clear flow from first nodes of the cluster to the end nodes that are mainly the beneficiaries of the transformation of such side streams that will gain value through the different steps of the value chains. In terms of specific nodes of the cluster, we have PL boxes manufacturing, so technologies involved here. PLA, polylactic acid recycling plants, so there is a technology again involved, regulations. We have retailers that are using PLA boxes, aquaculture industry, fish processing large industry, and fishermen. So the white ones are the side stream providers, so the first node of the ecosystem cluster. Then we have the pre-processing and the bioconversion processing. These benefit from a really innovative approach in order to transform side streams into powders or into matter that is useful for feeding new processes. And then at the second stage, or the third stage indeed of the value chains, we have bioactive extraction expert with the targeted technologies, and also bioplastic development and plastic recycling. All these flows, which gain value through the steps from first side stream, first node, down to the bioconversion and the bioactive extraction, well, those results into components, ingredients that will be exported in the cosmetic industry, in the nutraceutical industry, so basically cosmetic products, skincare products, nutrients and additives for and diets for human consumption, packaging, manufacturing of different materials, natural-based and also bio-based materials, and also recovered materials from fossil fuel origin. automotive industry, which will benefit from recovered PLA and PLA 66 materials, and agriculture and farming, which will benefit from the bioconversion process. And as can be seen, agriculture is connected to the fish industry, to the technology, since soil fertilizers will be used to obtain new PLA, so new agriculture side stream, which will provide PLA and feedback into the process of producing fish boxes. This is just to give you an example, but we will see in details all the circular value chains to clarify the flows and the partners, and as well as key actors. So another important point, the second key objective are the creation of a framework which is replicable in different circular socioeconomic clusters based in different areas. The one we are starting investigating is the Liguria one, but and we connect, of course, blue and green economy, but it's not the only CKO that we are targeting to, because we want to create a meta model, a system, and also tools that will allow us to study the replication of these success case. The second CKO is the implementation of unique patented technology provided by TEMIS. We call it the EPPU. This unit is benefiting from integration of technologies that allows to process in an efficient way side streams of different nature, and we will be able to obtain purified water as an output and powders with valuable added content that could be explored in industrial sectors that I was referring to before, especially cosmetics and nutraceutical sector. Then the EcoeFISHent will investigate the best processing parameters to obtain EcoeFISH powder. Okay, those powders have. I mean, this is the main challenging point of the project, to preserve the bioactive content. So this is not really a trivial stuff to start from unsorted side streams and to obtain still a good and relevant amount of bioactive content that could be exploited in an economic and efficient way. This makes EcoeFISHent different from all other challenges in this sector. And these powders will be also, of course, undergo fraction extraction, purification, to maximize the valorization of the powders obtained. And the whole conversion process will be devised in a way to preserve the bioactive properties of the sources. So this will be one of the key factors, also measuring the eco-efficiency of the technosphere processes involved. In terms of units of implementations, well, we will have 2 pilots with a capacity of 1 ton per day, so they will be able to process 1 ton per day, and they will be located and set up at Generale Conserve and Acqua partners, so in Sardinia and in Liguria, and using appropriate mechanical components to withstand a predetermined processing flow rate. So the feeding of the side stream will be specific, custom, based on the side stream nature and consistency. The system will also be characterized by specific technology characteristics, like reaction jack chamber, including shredder and mixer to operate under vacuum conditions. And this is very important because vacuum condition will somehow preserve the bio content of the side stream, avoiding use of thermal sources in order to operate this powder production. And then heating exchange system for energy recovery. The energy used could be also connected to the local premises, thermal energy exploitation. And the microwave source for waste material treatment will be used in order to somehow trigger the right thermal energy input into the bio base side stream. Vapor condenser will allow providing purified water to be used in the second stages. And one liquid ring pump auxiliary system will operate and support the whole unit, both units to be installed at the two partners' premises. Okay, here we see what has been obtained already from the first test campaigns. And starting from tuna samples, high humidity and using the EPPU process, which is WRT patented, working at temperature lower than 54 degrees. As I was mentioning before, temperature is an issue because we are dealing with organic materials. In order to preserve the organic materials valuable content, so temperature has to be kept low. That's why vacuum is used as well. And pressure is between 0.3 and 0.4 bars, so we are in depressurized environments. We cannot call it vacuum, but it's depressurization environment. And this will allow to use to extract water, the water content from the material, and to obtain dry products. The water reduction was about 95%, and the dry matter between 92 and 96% obtained. So this is a quite efficient way to obtain on one side purified water, and on the other powder with still valuable content. Here are some pictures of raw tuna and tuna raw, for cooked tuna. Yeah. So let's switch to the other key cluster objective. Obtain bioactive compounds with a high market potential and added value. To reduce the reliance on high cost and scarce protein-rich resources, as fish oil and meal, which are already obtained by these side streams, but which somehow underexploit this valuable content. And then to provide higher added value bioactives for final products in nutraceutical, cosmetic, and bioplastics sectors. Indeed, one of the obtained compounds is gelatin. So the idea is to leverage the valuable content, but in order to do so, we have to address to new technology. So this WRT is an enabling technology, is somehow the pivot of the project implementation. Here are the flow charts that somehow explain the inflow and outflow of the central depicted here. I don't know if you see my mouse, but this is the unit to obtain the powders. So we have aqua, cope, and generally conserved side stream, which are the fish processing side stream entering into the system, which requires, of course, energy to be powered and to work. The outputs, as I was mentioning before, are the EcoeFISHent powders and EcoFish powders and water, purified water. The EcoFish powder will is being transferred to UNIJ, Vacqua, and Nofima for investigating the best extraction processes to obtain gelatin and bioactives. This is referring to the investigation and the research and development stage of the cluster implementation. Key objective number 4, the cluster. We want to define the best logistics scenario of the EcoeFISHent cluster, an industrial symbiosis system to guarantee efficiency, cost effectiveness, and lowest environmental footprint. Well, very challenging objective. Logistic is not a secondary part in the cluster, because in order to optimize the transfer of materials and exploitation of energy, we need an harmonized system that will call in material inbounds at different nodes of the cluster at the right time, in the right amount, to avoid spoilage of materials, to avoid over consumption of energy, due to preservation of the biomaterials at the right temperature, etc., etc. So this is also a very important point in the design and development of the cluster, logistic scenarios, studies, and implementation. And here we see the interconnection of the different value chains. So as we were mentioning before, it's a multi-circular cluster, and the circularity you can appreciate here. Then we can comment briefly the circular value chains. And we want to stress the point that there is interconnection in the circular value chains, and not only within the circular value chain, but also among actors, which are beneficiaries and providers, in order to obtain a system, a cluster of symbiosis involving industries. Another important point is that we span from green economy to blue economy and back to green economy, vice versa, in order to involve all the territorial valuable sources for economy and for the environment as the same time. And very important to say that we are pointing to go 100% circular. So we have a cradle-to-cradle approach in order to interact, as I was mentioning before, in the best way, in the best harmonized way between ecosystem and ecosphere, and technosphere. Last but not least, offering circular products. So products are bio-based, and those materials are obtained by the ecosphere after transformation and exploitation of side streams, which would be under-evaluated or under-exploited according to the traditional linear economy model. And also obtaining renewable energy, not only in materials, out of the side stream. So very important, complete approach. It's a holistic view of the circular system. So let's look at this first circular value chain, which is starting from agriculture side stream, which will enable extraction of a polylactic acid, which will be further converted into EcoeFISH boxes made of expanded polylactic acid instead of polystyrene. So shifted from a fossil fuel to a bio-based resource to produce fish boxes, which could be used within the cluster. Okay, this will of course injected into the fish industry, because fish boxes are used to carry fish. Okay, so products that will be sold in the market locally, but the fish boxes have themselves a life cycle. So by the end of their life cycle, we have to manage waste to some extent. Okay, instead of looking at waste, we have a concept of side streams, and this concept has been applied also to these materials. So in the end, the EcoeFISH boxes being made of expanded polylactic acid will be possible to be recycled or reprocessed into bio substances, which will turn into fertilizers and soil improvers. And in this sense, this will allow to circulate the value. Okay, So let's focus on another, for instance, value chain, which was the one mentioned before. So from fish industry side stream, we get the pre-processing to get EcoeFISHent powders through the unit we were discussing before, the EPU. Then we get bioactives, which will be used to produce bioplastics, for instance, from gelatin, so barrier coatings, injected again into the industrial system, so into the technosphere depicted here by the blue dot. And well, bioactive extraction will also be used for supplements, in nutraceutical applications, and in cosmetics. Well, the processing will involve also the production of bio-based sources for breeding black soldier fly larvae, will end into other valuable components like oil to produce energy, and chitin that will be used again in the cosmetic sector. Looking at a broader circular value chain, we see that also we have fishing and aquaculture nets from the fish industry, which are somehow end-of-life products, so nets used for fish industry, which can be recovered and recycled in order to produce components, automotive components in the car industry. Part of them, well, this is from the PLA source, mainly nets, fishing nets, but we also have some polyethylene materials that can be used and injected into the cosmetic industry by producing cosmetic packaging. So from this chart, you really appreciate the interconnection among the different value chains and how each value chain supports, to some extent, other value chains in order to be implemented in a whole circularity and holistic view. Okay, we are now to the cluster key objective number 5. We want to develop an EcoeFISHent logistic cloud platform. So logistic was referred to real material flows, but how to manage those material flows and to manage the information like the calling and sending, so inbound and outbound of material flows through the nodes of each node of the cluster. Well, we need a logistic cloud platform for the streams to be managed and sent and received at the right time. So material flow in terms of collection, pickup, storage, pre-treatment, processing on the timeline will be managed by the logistic cloud platform. This will enable us to optimize communication among the nodes, among actors, the collaboration, the logistic network, and also among the value chain stakeholders in order to harmonize and to direct in the best way the orchestra. So this is just a good analog to see all the nodes of the cluster as instruments that have to play the same rhythm and the same music. Okay, well, the implementation of the IT-based system is the CIAP, so the EcoeFISHent Logistic Cloud Platform hub, which will somehow interconnect. Well, this is the architecture of the system. We'll just briefly describe this. And this is a platform core, so we have user management, communication tools, registers and databases, logistic transactions. Everything is monitored and stored and transferred and converted into digital form. We have the portal that is somehow providing also computation and algorithms to monitor the key performance indicators, like KPIs. We have analytic module, which is enables to manage and process data. We have interfaces, human interfaces like desktop services, in order to provide data input and output, and to have monitor the capture of data from ground, so through the IoT sensors, scanners that will feed the system with data, so the conversion from physical information to digital information. And then the users, the nodes that are interconnected in the platform are of course the FFS and FCP, so the providers of material flows from the starting nodes and transport of fish eye streams and powders, producers and intermediaries, and final product or intermediate and final products, so powders production, extraction, and conversion into valuable products to be finally sold onto the market. And among all the nodes, of course, there will be the logistic actors that will be, of course, interconnected to this system. We are now to the key objective number 6 of the cluster. So this is a quite specific objective, converting gelatin extraction from FCP into a barrier polymer coating for packaging for oxidation sensitive food. So barrier to oxygen and whatever as well. And this will be used, of course, for meat, fish, cheese packaging, so food packaging basically, to substitute conventionally used fossil barrier polymers like EVOH, which is quite difficult to recycle, and we don't have the recycling problem here. So the gelatin is being characterized, analyzed according to its physical, chemical properties and functional properties as well. And this is the first step for the preparation of a suitable gelatin solution for barrier coating. So the investigation, optimization studies are still underway with very good results and promising outcomes. The packaging barrier coating will be obtained through this gelatin, obtaining a gelatin barrier coating which will develop starting from lacquer coating at small scale, and then it will be produced by casting, lighting, dye coating, nib coating, and spray coating. So there are different technologies which are considered in order to convert this gelatin onto the substrate and to obtain the barrier functionality on top of the polymer-based substrates for packaging. And of course, each solution obtained will be characterized under its optical aspects. And the thermal stability is another important point, and also in relation to the antioxidant capacity on top of oxygen and water vapor barrier properties, which are the main addressed in this application. Number 7, cluster T objective 7 is reaching a 100% circularity of the fish eye stream sources, which are processable with the EPPU, and to feed also the BioSF larvae. So the fish side streams which are not processable in terms of extraction of valuable components for bioactives will be used anyway to obtain the feed for the value chain involving black soldier fly larvae, which will provide valuable bio-based materials for oil, biodiesel, and soil improvers, as well as chitin for cosmetics. So this is really the holistic view that enables to valorize all side stream and sub-side stream of the processing at each processing step. Here we see the process by conversion in the EcoeFISHent perspective, just to clarify how this value chain works. So the controlled breakdown in initial feedstock of food waste into insects, biomass plus, is somehow mirroring the natural breakdown of organic matter into an ecosystem. And the black soldier fly is the bioconversion engine that will transform this side stream into EcoeFISHent thrust. So this is the soil improver, and oil that will be extracted from larvae, and EcoeFISHent chitin, which is obtained by the organisms that are grown on side streams. CKO8, replacing the linear model for the boxes, which are currently expanded polystyrene boxes, largely used in several applications in fish industry and commerce, so at the retailer sites, by implementing a full circular system for expanding polylactic foam based on biofoam trademark. Boxes derived from agricultural residues and totally compostable. So we already discussed this value chain. This was just to stress the point that it is a specific key objective that is aims at substituting progressively the polystyrene boxes, which are not, which are recyclable, yes, now, previously not recycled, but then filled in the past. But now they should be replaced with the bio-based sources, bio-based material, and fed back into the agriculture circular value chain in order to obtain, again, bio-based side streams and, of course, edible products. So what's special about these EcoeFISH boxes? So they rely on a new design, patent design, which will implement and enhance the efficiency of the logistic part, since normally fish boxes have a footprint and dimension which can be reduced when they are transported in the empty state. So basically, the load factor of carriers is the same as the load factor of fish boxes which are carrying fish. So this implies that there is an excess of fuel consumption in transport, and by halving the size of the empty fish boxes volume, so by doubling the load factor per unit of transport, we are able to demonstrate that more than 50% reduction in environmental impact may be attained in terms of CO2 and of NOx emissions, which is not trivial as a gaining factor. And well, at the end of life of those EcoeFISH boxes, so polylactic, expanded polylactic acids, well, they will go into a thermal-mechanical composting process, which will end up into a soil improver. So this is a kind of second life of this bio-based material, which enhances and supports also the production of new bio-based materials and also food, because we are offering valuable sources for the agriculture sector. Now, looking at the ninth key objective of the cluster, we look to technosphere and fossil-based materials from fossil origin, which are polylactic acids, polyamides, 6-polyamide 66, as well as polyethylene. So far, it's not possible to manufacture nets or gears used for fishing and fish cages in bio-based materials, since the mechanical properties of polyamide and polyethylene cannot be currently substituted. So maybe in the future, yes, but so far we have to deal with this bio-based, with these fossil-based materials, which anyway can enter into a circular value chain So the waste and the end-of-life nets can be exploited in order to obtain new polyamide and polyethylene, which is pelletized after a washing cycle, after pre-processing, and then by extrusion and molding be converted into other valuable components. One, as I was mentioning before, is car components. Here we see a car bracket. It's a component of car. And cosmetic packaging. So we use this waste, which currently is really a problem because there is also somehow common practice or by accident, these are left into the sea. So these are a source of pollution, a continuous pollution, unwanted bycatch into the sea. So we are basically killing species, unwanted killing species by discarding these nets into the sea. So by somehow creating value out of this waste, which currently is a burden, is a cost for fishermen and for fish industry, we are unable to start a virtuous circle that will, on one side, to preserve the ecosystem, on the other side, to create value and to also leverage and induce new work opportunities for the technosphere in the cosmetic, packaging, and industrial components, automotive industrial component sectors. CK10, to implement sustainable fishing practices by testing a great aim at improving the exploitation pattern and reducing discard rates in the deep towel fisheries targeting red streams in the Ligurian Sea, which is, by the way, a FAO and the Geographical Superior 9 protected area in order to improve selecting fishing and reducing bycatch. So this is practice, designing, creativity, and also technology in order to exploit what needs to be exploited in the best efficient way. So this has to do directly with the ecosystem and the harmonization between ecosphere, technosphere, and blue economy, supporting also the food industry. Few technical details on these techniques. So the idea is to have a code and improvement in order to, and this will be obtained by grid improvement, which will somehow select the species or the sizes of animals and fish that will be obtained by the fishing activity by preserving also the fish regeneration and avoid catching too young species. And this, I'm not an expert in this, but you will see by drawings that the technical specification of the experimental code ends is explicit here, and the special installation is provided, and also the management of the net meshes is an important part in order to trim the right size of the net in order to have targeted catching and to avoid bycatch, which is one of the main problems. So this is explained here with nice picture, technical one, and also we can see here a sample of net, which is manufactured and optimized according to this new design with the grid in the code end. There is another point regarding the ecosphere, and especially referring to the marine protected area in Liguria. By the fishing activities, there are some discarded into the sea, and those are named Ghost Gear. So there's a program that is led by WWF, which is the Ghost Gear, Stop Ghost Gear program. And this is aimed at removing abandoned nets into the seabed of the GSA 9, which is a specific marine protected area in the area of Portofino. And this allows also to avoid unwanted bycatch. So there are fish that get stuck into these entangled fish nets and the fishing lines that are found into the seabed of the area. This is not only dangerous for fish species, but also for living stuff which are attached to the seabed and into the rocks like corals. Then we switch to the 12th objective. So as you can see, this project has many key objectives. This is to implement an eco-design approach to ensure the lowest environmental footprint of the whole cluster functional system, which involves processes, logistics, and final product efficiency. And this will be addressed by analyzing each node of the system, each material flow from node to node within the cluster, through the life cycle assessment methodology, life cycle costing methodology, and life cycle and social life cycle assessment. So the holistic approach is there, but it's not general or narrative. It's based on a quantitative assessment, so on measurements, on the studying of scenarios, on sensitivity analysis, which will allow us to optimize each process by taking into account the whole system. So having a full balance of the environmental impacts of generated or avoided by the cluster. Few words about this magic word, which is a buzzword called sustainability. So what is sustainability? Well, there is a official definition, and this dates back to the 1987 Brundtland report, which stated our common future as developments that meets the needs of the present without compromising the ability of future generations to meet their own needs. So the sustainability concept puts a focus on future generations, future interaction between environments and humans, so technosphere, ecosphere. And this is based on 3 pillars, which are planet, so environmental sustainability, people, so the social sustainability, and the economic sustainability, so prosperity. These pillars, these dimensions, as I call them, are interconnected. So we cannot consider analysis or considering sustainability dimension alone. All of them are strictly interconnected. So what people do have a reflect on environmental impacts, and the environmental impacts reflect back to the social impacts and that are somehow to be managed and bear by humans. And of course, good social condition, good environmental condition enable prosperity and economic development, which is sustainable as it is according to this concept. So planet, people, and prosperity are three dimensions from the same reality. As long as we will consider these as a whole, then we will be able to devise harmonized and holistic solutions, as we are targeting within the EcoeFISHent challenge. As we were mentioning, sustainability is not an abstract concept. There's a special declination in dimensions, and each dimension is subject to metrology. So we are able really to assess in a quantitative way what are the impacts, the effects, and the feedback of those dimensions and their interconnection. And the methodologies to assess in a quantitative way the impacts are the life cycle assessment, which is a standardized methodology, the life cycle costing methodology, which is fed by the same data collected by the inventory phase in the life cycle assessment, and at the same phase, the conversion of this information, this primary and secondary data, will be converted into social impact categories. So we'll be able to address and assess the impacts on environment, on economy, and on social life in a quantitative way at regionalized and global level. This will allow to provide gap analysis sensitivity to identify the major sources of impact and to take informed decisions on how to optimize the system, processes, and the whole logistic of the address EcoeFISHent cluster. Just really a few highlights in life cycle assessment. We already provided classes on that, and I think the material is available also online. But well, what is LCA? What is life cycle assessment? Basically, it's energy material balance made on a system which has a specified boundary system, which has specified boundaries of the system. And this is somehow addressing the life cycle of each flows, each material, each product, from raw material extraction, transportation, transformation, production, use phase, end of life, recycling, and all these phases correspond somehow to a node of our cluster for each value chain and for each valuable content materials and finally products. So this can be assessed by monitoring the inflow and outflow in terms of materials, energy, raw materials, products, and emissions to the environment. And these slides clearly shows this concept in terms of inbound and outbound. So inputs in terms of raw materials, resources, energy, and emissions to the environment in different environmental compartments like air, soil, water, at each step of the transformation through the value chain. Normally, in a linear economy concept, we have from cradle to gate analysis or from cradle to grave. Well, the innovative approach of EcoeFISHent cluster is to have a cradle to cradle approach. So by analyzing in a circular way the material flows and to provide overall balance. Also referring, according to a comparative approach, to linear, current linear economy models. So in this sense, we'll be able to compare between the current situation and what we are addressing as a more sustainable solution based on circular concept and circular models. This concept and this methodology applies also to life cycle costing. So by gathering information in the inventory phase, which is the first phase, or second phase indeed, of the life cycle assessment, we will be able to convert all these primary and secondary data into costs, into economic value, which may be negative if it is cost, or positive, it will be a positive value generated. So, which is one of the aims of EcoeFISHent cluster. This considers, of course, initial cost, service cost, preventive maintenance cost, and operating cost of each node, and disposal cost. So if you want to focus on a node, for instance, just to give you an example, you want to analyze the conversion of side stream into powders. So we have at least two outputs. One is the valuable bioactive content powder, and the other is water. So water has an economic value and could be reprocessed. And then we have also energy, excess of thermal energy that can be exported at the site where the EcoeFISHent powder production unit is installed. But of course, we have cost. So these are values. Costs are running costs, are the cost for investments, are the cost for the change in consumables, changing of parts, and as well as human resources, etc., etc. The premises costs, renting or mortgage, etc. So all these cost flow and cost streams are accounted for each node, and we are able to provide the overall balance of the cost assessment and value generated. The information gathered in the analysis of each node and inter-node and node interconnections is also exported in social life cycle assessments by providing a social assessment according to a top-down approach, in the regionalized approach. This is conducted following the ISO standards, which are specifically targeted to environmental impact assessment, but which are directly transferred and converted into the social life cycle assessment, also according to UNEP guidelines. And we will end up, as we do for the environmental impact categories, with social impact categories that are connected to the interaction within the cluster and production, consumption, disposal, sources, material sources, and sources of energy, kind of energy, stakeholders involved, and this has a really broader impact, social impact, than the impact that can be assessed locally onto the cluster area. Okay, we are now to cluster key objective number 13. Okay, and this is somehow aiming at promoting marine ecosystem protection and regeneration through the action of avoiding and lowering bycatch rates, cleaning seabed from ghost gears, and avoiding further marine discard, avoiding EPS boxes use, polystyrene boxes, as I was mentioning, landfilling, which is now forbidden, or causing marine litter due to their voluntary or accidental discard into the sea. So by it's a somehow sustainable by design approach. So we want to avoid, we want to implement preventive strategies instead of curing at the end the damage has already been put in place. So the idea is to support case-by-case studies of fishery discard to analyze the impact of the removal and reintroduction of bycatch into marine ecosystems. So this will be also analyzed under the LCA, social LCA, and costing, under the costing point of view. So if this is really efficient under the economic, social, and the environmental point of view. So the numbers will say the final word on that and how to implement these in order to get to the addressed objectives. The objective number 14 is related to the development of the cluster digital twin, which is somehow an enabling tool which will support the cluster business model, analysis, optimization, and also replication, the enlargement for future extensions to many actors and stakeholders locally, but also in other sites to assure economic sustainability, resilience of the system, continuous efficiency over time, and cluster economic expansion. So the idea is to scale up the cluster locally, but also to provide replicability, a good ground from replicability. No, thank you. So as it was already pointed out before, in order to create a digital twin, we have to somehow interconnect the physical world with the digital world. And to do that, we need to make use of systems, IoTs, barcode readers, and other devices in order to capture information, data on the ground that will be converted into digital data and finally to valuable information after processing. So basically, what are the categories of information or data that we will get from the ground? Those will be material flows, the energy flows, and the value stream. So we are basically assessing material and immaterial data, which will be digitalized, analyzed, monitored, and computed in order to obtain the performance of the system and subsystem within each circular value chain, and by interconnecting the different value chains in order to provide a global overall optimization of the system. But in order to optimize, we need to measure. So out of the primary data that will be collected on the ground, we will address specific KPIs, so the key performance indicators. And well, just to give a few examples, economic key performance indicator could be the cost of processes. So this has a unit of measurement, which is euros. And for the environmental impact, we may address to 11 KPIs. One of them is the most very well known global warming potential, which is the CO2 equivalent emitted in the atmosphere, inducing and somehow causing the global climate change, warming of global system, and other KPIs which will be more specific and will allow us to monitor and to measure, to quantify the efficiency of the system. So this is a key enabler in with data-driven decision making. So decisions on the best optimization of design and changing of the cluster would be based on informed decisions. And what's more important is that the complex system monitoring will be somehow simplified into a simplified reporting methodology. Okay, this is just to provide you the chart, the concept that were already been provided before. So from the physical cluster, capturing data, and then getting at a high level to the digital system. Number 15, key objective number 15 is the design and defining of pipeline of investments that are targeted to support and promote the EcoeFISHent in the processes of internationalization, encourage twinning actions, and all other activities which will enable cooperation between partners within the consortium and outside the consortium with foreign companies in order to extend, to replicate, to promote this system for growing blue economy and beyond the economy sector. This, of course, will involve the institutions and various sectors to promote programs and investments that will fuel the implementation of similar success stories. And well, Filsa is the coordinator of these key objectives and will support the project to create an international pipeline of investments, promoting and implementing the improvement programs and actions aimed at attracting investors and involving local communities, supported by dissemination plans. So from ideas to real-world implementation beyond the boundaries of the eco sites and cluster. We have another key objective in EcoeFISHent, which is involving local communities by offering new job opportunities, so leveraging the value that has been created, and also to support disadvantaged workers in order to also launch new behavioral patterns for nudging activities, which is a technique in order to force in a good way the actors, the stakeholders to take decision and to implement good practices in order to assure the real whole cluster implementation. This involves fishermen, fishmongers and retailers, as well as citizens and consumers, which will be driven to support the implementation of this design, which is a community-based challenge involving all stakeholders in this scheme. Well, the national activities involve consumers and citizens, and of course try to leverage and to promote new responsible practices from the starting point, from the first nodes of the cluster down to the end user or buyers that will be guided into valuable and virtuous behavior. This involves, of course, all the value chains and including fish, cosmetic, nutraceutical, well, also agriculture, to adopt sustainable behaviors related to the blue economies. Okay, so here we have some figures that are clearly specifying what is the impact and involvement of stakeholders, which is not really negligible. So time is running, so I would skip some slides, or just briefly telling you, fish retailers will be involved, and of course push to use the EPL boxes and to address the value that they are handling. Fishermen in good fishing practices, and also providing goods end of life of those nets, as we mentioned before. And finally, the transfer, the replication of this model into Galicia and Nairobi areas, so Spain and Kenya, which of course will have different drivers, different environmental and boundary stresses of the system, which will be studied and optimized and modeled through the digital system and model that will be obtained by the data processing. So why is Galicia involved in this experiment? Well, because Galicia is a very important fishing and aquaculture sector, contributing more than 10% of the region GDP, so quite relevant. And there is no need for a circular economy approach to transform byproducts and effluents from the canning industry into high value added products. So this canning factory, which is in Galicia area, can produce significant byproducts like 300 to 4,000 tons per year in wastewater in the amount of 100,000 meter cubes per year. So it's very important to implement sustainable practices and to exploit value of this area. For what pertaining Kenya, well, the project assesses the potential of a multi-level circular clustering in Kenya to recognize the significance of the blue economy and leverage local blue economy into economic development and local livelihood. So also, of course, having a social impact in the area. And PEDEC is the partners involved from Africa, from Kenya, improving the quality of fish products, and from the redistribution of value into collective action among traders, promoting sustainable fishing practices in Europe, empowering also local fisher folk. Okay, this is numbers and KPIs related to the Kenyan area. just to highlight the employment opportunities, which will really have a huge impact in the area for creating new job profiles and new job opportunities, and reducing the gap, the social gap that is currently seen. CKO 18, development of a mathematical model to assess different economic instruments, including pricing policies, tax incentives, subsidies, and all other factors that will enable the sustainability and circularity goals attainment, and also the implementation of the eco-efficient circular value chain. Okay, so I think that we are running out of time. Let's see if we can get, yeah. Okay, basically we are come to an end, almost. Yes, I want to skip all the other slides, and well, there's enough material maybe for further classes and meetings. Yeah, thank you for your attention.
Thank you so much to our professors. And now I leave the floor to Professor Chiara Fantinuoli from TICAS, who is going to